Hello, everyone. Today we are going to begin the discussion of Chapter 4, the time value of money. Let me share my slides with you. Okay, this chapter is very important. Yeah, because in this chapter we are going to discuss one of the most important principle in finance. That is, money has a time value, and this principle is a foundation of all topics in finance that we're going to understand in this course. Okay, in this chapter, we're going to have three sections. We're going to discuss the future value, the present value, and the application of future value and the present value. And you should read all sections in this chapter. I like to begin with a story. This story will help you better understand the time value of money. The story comes from Everybody Loves Raymond. This is a sitcom that was very popular in the early 2000s. This is this was the early years. I came to the United States. I watched this sitcom almost every day. I have learned a lot of English from this TV series. Okay. Let me simply introduce the episode. Okay. One evening, Raymond told his wife, Deborah, that he lost $23,000 in card gambling to his father, Frank. Deborah was upset with that. She yelled at Raymond again and again. We need money to move to a house away from your parents. We need to save money for the children's college. But you lost money, in gambling. However, fortunately, you lost to your father. You can get the money back. The Raymond said, I cannot do that. I'm not a child. But Deborah kept yelling again and again. Finally, Timmy said, okay, all right, I'm going to get the money back. When? Deborah asked. Raymond answered, when he dies. With this answer, Raymond means he can get the money back from his father's inheritance, right? When his father dies. Okay, after this episode impressed me and helped me have a better understanding of finance or the time value of money. Here, after this story, I like to ask a question. Do you think the $2,300 that Raymond expects to get back when his father passes away have the same value as the $2,300 that Raymond lost in gambling today? Okay, let me repeat the question. Okay, do you think the $2,300 Raymond expects to receive from his father's inheritance have the same value as the $2,300 that Raymond lost in gambling to his father today? Okay, of course, I think the answer is no. Why? because now we know money has time value. Simply speaking, $1 in hand today is worth more than $1 you expect to receive in the future. Okay, so this is the beginning of this chapter, and in order to understand the time value of money, we should have a review of math. I call this math the growth issue. Okay, and the math about the growth issue is very important in finance. We're going to use a lot of this math in finance. In order to understand this growth issue, I'm going to explain with an example. You got a job, and your beginning salary is $50,000 per year. Okay, and I name this variable as your beginning salary as S0, and your boss or your employer promises that your salary will increase by 1% after first year. That means your second salary will be higher than your first year salary by 1%. What does this mean? That means your salary is growing, right? It's growing. Then in this case, what is your salary in second year? Or in the other word, how many dollars will you earn after you will have worked for 1 year? First, we name this salary. We name your second year salary as S1. Why I use S1? Because S1 begins from the first year or first year end, right? Okay, then what is your salary at the end of the first year, or what is your salary in the second year? This is the math. Okay, simply we can find out with the intuition. Okay, now I use S1, right? S1, that is your second year salary, or the first year end salary. Of course, first year end salary includes the beginning salary, that is $50,000, plus the increase. How much is the increase? Increase is 1%. Your salary will be higher. Your second year salary will be higher than the first year salary, than the beginning salary by 1%. By 1%. Then in this case, it is easy for us to calculate the increase. That should be beginning salary times the increase. Here, I use the decimal. 1% in decimal, that is 0.01, right? Okay, and then in this case, it is easy for us to calculate. Okay, the beginning salary, $50,000 plus the increase. The increase is 50,000 times 0.01. That is $500, right? That is $500. Come on. Okay, and then we know your second year salary or your first year end salary is $50,500. Okay. However, here, what I want is find a formula to do this. I don't want to do this step by step because it costs much of the time. Okay. Now, yeah, with the small math, now we can find $50,000 in the first term, and okay, $50,000 in the first term and $50,000 in the second term. That is a common factor. We can factor out this common factor, so we can write the calculation as $50,000 times 1 plus 0.01. Okay, and then yeah, you can do the calculation. $50,000 times 1.01, then we can get we can get $50,500. That is your second year salary, right? With this formula, we can calculate your second year salary or your first year end salary. Okay, because we use notation S0 to represent the 50,000. Then yeah, we can write this as S0 times 1 plus 0.01. Right? Okay, so that is now yeah, in this slide we look at a growth over a single period over 1 year. Here, yeah, the unit of period is 1 year. We look at the growth over a single period, right? Of course, the growth over one single period is not good enough. Yeah, in the real world, yeah, we can, yeah, your salary will be growing over several years. Now let's look at the growth issue in 2 years. The same issue. You get a job and your beginning salary is $50,000. That is the same information as in the last slides. Now your employer promises that your salary will increase or grow by 1% and 2% after first year and the second year, respectively. Then what is your salary in third year? In the other word, how many dollars will you earn after you will have worked for 2 years? Okay, we name this salary, your salary in the third year as, okay, sorry, yeah, there is a typo. Okay. There is a typo. Okay, here, as. All right. Okay. We name this salary your salary in the third year as S2. As S2 because it begins, this salary begins from the end of second year, from the second year end, right? Okay. Now, first of all, we begin with a simplicity. Okay. First of all, let's look at a 1 year growth. Okay, now we have a timeline, and the issue is over 2 years timeline. Okay, here it is time 0, and this is the year, first year end. This is second year end. Now let's look at a single period. Yeah, that is the second year. Okay, the second year. From the second year, based on what we had in the last period, we know at the end of year one, your salary is $50,500. Okay, and then during the second year, your salary will be growing at 2%. at 2%. Then how much will you have at the end of the second year, right? Okay, and I think over this single period, now by intuition, it is very easy for us to find out your second year end salary or your second year end salary, right? So just as I said, we name your second year end salary as S2. Then S2 equals the first year end salary, $5,500 plus the $50,500 times the growth rate. Growth rate is 2%, right? It's 2%. Okay, and of course, we can get this number. Okay, the number is $51,510. Okay, if we do the calculation, of course, our interest is in a formula. We want to get a formula to calculate the second second year end salary. Okay, now this is the common factor in the term term one in the first term. This is the common factor in the second term. We can factor this common factor out. Then we can write this as 5,500 times 1 times 1 plus 0.02, right? Okay, if you do the calculation, you can, I believe you can get the same number. We can get the same result. Okay. Now the point is we want to look at the two periods as a whole. Okay, we want to look at the 2 periods, 2 years as a whole. Okay, now let's look at this one. This is the first year end salary, right? And in the previous price, we know 50,500 equals in the first price. Okay, we know 50,500 equals 50,000 times 1 plus 0.01, right? Okay. Now we replace 50,500 with this expression. Okay. Then that is 50,500. Okay, and then don't forget this one times 1 plus 0.02. Now we can see. Okay, what is the second year end salary? Second year, if we look at 2 years as a whole, then we can find the second year end salary is the beginning salary times 1 plus first year growth rate, then times 1 plus second year grade, right? Okay, if you do the calculation, I believe you can get the same number. Okay, or in the other words, we can write this as, because the 50,000 is the beginning value, is your first year salary, right? We use this we use S1 to represent your beginning salary, so we can write this as S1 times 1 plus the first year growth rate, then times 1 plus second year growth rate, right? Okay, okay. So now, yeah, our issue has become a little bit complicated, but in the real world, it could be more complicated, right? How about the growth issue in 3 years? In 3 years. Okay, the same question, but right now, yeah, your employer promises that your salary will increase or grow by 1%, 2%, and 3% after first year, second year, and third year, respectively. Now you want to know what is your salary in fourth year, or how many dollars will you earn after you will have worked for 3 years. Again, yeah, we name this salary, your salary in the fourth year, as S3 because it begins from the, okay, from, from the third year end. Okay, yeah, here is the table. We name this salary as S3 because it begins. Here we go. Okay, I think that is fine. What's the end? Second. Okay, yeah, yes, yeah. This is that is 30-year end. Okay, 30-year end. Okay. Of course, we begin with simplicity. Yeah, that means we're going to look at 1 year period first. Okay. Now we have a timeline. We have a 3-year timeline. That is the end of year 1. That is the end of year 2. And then this is the end of year 3. Okay. First of all, let's look at 1 year. That is the third year. Okay, from the year end 2 to the year end 3. Okay, and just now we know your salary at the end of the second year is 2. That is $51,510, right? Okay, and during the third year, your salary will be growing at 3%. At 3%. Then how many dollars you will receive at the end of the third year? Okay. Now let's look at this single period. Let's look at this growth over this 1 year, single year. Of course, if we use S3 to represent your salary at the end of year 3. Okay, or if we use S3 to represent your salary in the fourth year, then S3 equals 51 equals $51,510 times $51,510. Oh, sorry, plus, here is plus, right? That is your beginning salary, then plus the increase. Yeah, that is the second year end salary, then plus the increase in the third year. The increase is $51,510 times the growth rate. Growth rate is 3%. In decimal, that is 0.03. Okay, of course, yeah, if we calculate, then yeah, we get your S3 or third year end salary would be $55.30. Okay, so we can get this number step by step by intuition. However, of course, just as I said, in this we want to find a formula to get, yeah, actually our objective is to find a formula to get the ending value over a growth period. Okay, so now let's look at the, in this calculation, let's look at the first term and the second term. We can find the common factor, that is 51, sorry, here, 51,510, right? We factor out this 51,510. Okay, and then we get $51,510 times 1 plus 1 plus 0.03. Okay. Now, if we do the calculation, we can get the same result. However, this is not what I wanted. Now, let's look at 51,510. How can we get this number from the previous slides? We can find out, right? 51,510 equals 50,000 times 1 plus 0.01 times 1 plus 0.02. Okay, and then I'm going to replace this number with its original expression. So that is $50,000 times 1 plus 0.01, then times 1 plus 0.02. Okay, this expression represents $51,510, right? And don't forget this one, because we want to find out. Yeah, don't forget this one. So in order to get the 30-year end salary, yeah, we have to continue by continue multiplying this one by 1 plus 0.03. Okay. Now, if we do the calculation, we can get the same number. That is $53,055.30. Okay. Now let's have a closer look at this expression. S3. Now we can see S3 equals the beginning, yeah, your beginning salary, $50,000 times 1 plus the growth rate in the first year, then times the growth rate in the second, then times 1 plus growth rate in the second year, and then times 1 plus growth rate in the third year, right? Okay. Now, after this, now we know, we can generalize this issue. We want to ask how many dollars, you are going to earn at T years if we know the growth rate over, if we know the growth rate in each period, in each years over T years. So if we generalize our issue, then we can have this one. In constant growth over T periods. Okay, now, in this slide, because I want to generalize our issue, so I'm going to use the notation, okay? And some students are not used to using the notation. You should learn, you should learn, okay? Now, let's look at a variable. Let's look at the variable. This variable could be salary. Later on, we can see this variable can be used to represent many different things. Okay. Now, a variable denoted by V. Okay, we name this variable as V. With the beginning value of V0, okay, the notation for the beginning value of this variable is V0. And this variable will be growing over T periods. Okay, here T could be any number from 0 to any number, right? And the periods could be year, could be quarter, could be month, whatever. And the growth rates in these periods, T1, T2, T3, I name period 1 as T1, period 2 as T2, and on. Of course, the last period, TT. And the growth rate, in these periods, R, R1, R2, R3, and RT, respectively. Okay, respectively. Okay, then I use R to represent the growth rate. Okay, now we want to know. What is the after this growth process, what is the ending value of V? What is the ending value of V? I use VT to represent the ending value of this variable at the end of the last period, or at the end of period TT. Okay. Now, let's have a timeline. Okay, over this timeline, we have T periods. So here it is the beginning, that is the beginning of first period. Then this point in timeline is the end of the first period. And this point is the end, represents the end of the second period. Okay, and on. Okay, over this timeline. Then this point represents the end, represents the beginning of the last period, right? So that should be T minus 1. And this point represents the end of the last period. So I name this point the T, okay? And from this point to this point represents, from this point to this point, it represents the last period, right? Okay, now, we know, the growth rate, at the beginning, the value of this variable is V0, and the growth rate during the period 1 is R1. Just as I said, R1 could be a number. R1 is a growth rate, is a number, right? It could be 1%, it could be 2%, whatever. And the growth rate during the second period is R2. Again, R2 is a growth rate, is a number. And then, of course, we have R3 and on and on. And over the last period, then the growth rate is RT. Okay. Now we want to know at the end, what is the value of this variable? Or what is the amount of this variable at the end of period t? I use VT to represent the value of this variable. Okay. Now, of course, it is. Now we can see, right? Of course, the value of this variable at the end of the last period can be calculated in this way. That is the beginning value of this variable times 1 plus the growth rate in the first period, R1 here, and times the 1 plus the growth rate in the second period times 1 plus growth rate in the third period, and on until times 1 plus the growth rate in the last period, RT, 1 plus RT. In this calculation, R should be in decimal. Okay, should be decimal. Okay, so then we have a formula. After t periods, the value of the variable Vt will be this one. Okay, so that is the math. That is simple. That is simple. And from our salary example, now we understand. Okay, we can use this math to calculate the ending value of a variable after a t period's growth. Okay, this math can be used in the real world. First of all, just now, we look at the salary. We look at the salary. Okay. If you know your salary at the beginning, if you know the growth rate in the future years, and then you can predict your ending salary, right? Okay, and this math can be used to calculate the dividend growth. Later, it is very important in finance. We're going to want to know how fast the dividend is growing, and after a t period, that what is the ending period? Okay, later on, we're going to use this math to calculate the dividend growth. Okay, and of course, some of you have learned, have taken the economics. In the economics, GDP growth is very important, right? GDP growth, represents how fast the people in one country improve their living quality, right? So we can use this one to calculate the ending value of the GDP. Okay, if GDP keeps growing over p periods. Okay, and then we can calculate, this math can be used in the inflation. For example, if we know a basket of goods and service at the beginning is $100, and now let's say over 5 years, 1, 2, 3, 4, 5. Over 5 years, we have experienced the inflation rate. In the year 1 is H1, in the year 2 is H2. Okay, and on in the last year H5. Okay, we over these 5 years, we have experienced the inflation. We know the inflation rate in each year. Then we want to know, okay, for the same basket of goods and services, now how many dollars do you have to pay to buy the same basket of goods and services? Okay, now the question is, after 5 years inflation, how many dollars do you have to pay to purchase the same basket of goods and services? This is a growth problem, right? In this issue, the dollars you're going to pay to buy the same basket of goods and services is the variable, okay? And then how many dollars do you have to pay at the end of the year 5? That should be VT, right? Equals beginning value 100. Then times the 1 plus inflation rate in year 1, that is H1. Then times 1 plus inflation rate in year 2, that is H2. And on times 1 plus the inflation rate in the year 5. Then we can find out how many dollars you will pay to purchase the same basket of goods and services. In this case, the inflation rate is the growth rate, right? Okay, of course, in the real world, we can look at the value of an investment. When you invest your money in one asset, then the value of this investment will be growing in the future, right? Then in this case, the growth rate, later on we will know. In this case, the growth rate is, we call the growth rate the rate of return. I think, we know this term, right? We usually speak of return or rate of return in the investment. Actually, in the investment, the return or rate of return is nothing but the growth rate of the value of your investment. Okay, and then by using this math, we can find out, what is the cash value of your investment after you hold an investment for we can find out the cash value of your investment over your holding. Okay, initially, you invest. Now let's say, you invest $100. Okay, you hold your investment. Now, let's say you keep your investment for 3 years, and you know the rate of return in the year 1, that is R1, in the year 2, that is R2, and in the year 3 is R3. Okay, and then how many dollars are you going to have at the end of year 3? Then that is so the value of your investment is the variable, right? This variable keeps growing. Then the ending value should be beginning value. Your initial investment is $100 times 1 plus R1, then times 1 plus R2, then times 1 plus R3. Okay. Using this formula, we can find out the cash value of your investment after a holding period or at the end of the holding period. In this case, return, R1, is a growth rate. What is R1? R1 means the value of your investment at the end of period 1 is higher than the beginning value by R1, right? Suppose R1 is 8%. What does this mean? Yeah, suppose the rate of return during the first period is 8%. What does this mean? That means the value of your investment at the end of the year 1 is higher than the beginning value, is higher than the value at the beginning of year 1 by 8%. So essentially, in the investment, the rate of return is nothing but the growth rate of the value of your investment. All right. So that is the inconstant growth over n periods. Now, just now we assume, yeah, we assume each period has different growth rate, or growth rate varies from period to period, right? Yeah, during the period 1, the growth rate is R1. During the period 2, the growth rate is R2. Now, we look at a special case. Over these T periods, the growth rate is the same. Or we would like to say the growth rate is constant. Then what does this mean? That means, okay, during the year 1 or during the period 1, growth rate is R. Year 2, the growth rate is also R. Year 3, the growth rate is also R. And over these T periods, the growth rate is the same. So in the last period, the growth rate is R. Okay, then in this case, what is the ending value of this variable? Of course, that is easy, right? In this case, yeah, we're going to use this formula. Okay. However, in this formula, R1 is R, R2 is R, R3 is R, and on RT is R. Then in this case, we have a formula. Okay, we have a formula. The ending value Vt equals V0 times 1 plus R times 1 plus R. Times and on times 1 plus R until the last one. How many 1 plus R here? How many 1 plus R are there in this calculation? Of course, right? From 1 to T, right? From 1 to T. So yeah, we can write this as V0 times 1 plus R raised to the power of T, because there are T periods. There are T periods. Then we can jump to the next slide. Okay, constant growth over T periods. Okay, yeah, a variable donated by V with the beginning value of V0 will be growing over T periods. Growth rate are constant R in each period. Then after T periods, the value of the variable Vt will be, can be calculated with this formula. That is V0 times 1 plus R. R is a constant growth rate raised to the power of T. T is the number of periods. Okay. This, of course, when we use this formula, R should be in decimal. Okay. And this math can be applied in many real-life issues. Yeah, if we assume that the growth rate R is constant. For example, yeah, you can save an amount of dollars at your bank account, right? And your bank account promises, yeah, over the time, or over the holding periods of your, over the periods that you will hold your bank account, the interest rate is constant, right? Yeah, the interest rate, yeah, your bank will promise a constant interest rate. In this case, interest rate is the rate of return. The interest rate is the growth rate of your saving account. Okay, then in this case, yeah, we can use this formula to calculate how many dollars you're going to have if you hold your saving account for T periods or for T years. Okay, for example, you save now let's say $100 into your bank account, okay, in your bank account, and your bank account promises, okay, the monthly return is 1.2%. 1.2%. That is a monthly return. Now, what does this mean? That means if you save your money into your bank account at the end, yeah, and you hold your bank account for 1 month, then the dollars in your bank account at the end of the month will be higher than the dollars at the beginning of the month by 1.2%, right? So here, interest rate is the growth rate. Okay, and now suppose you hold, your bank account for 14 months. For 14 months, then how many dollars will you have at the end of the last month? Of course, we can use this formula, right? Because over 14 months, the interest rate is constant, or the growth rate of the value of your the growth rate is constant, and then yeah, we can find out how many dollars you're going to have at the end of the last month. That should be, yeah, use the formula, that should be $100 times 1 plus constant growth rate 1.2%. We have to use a decimal, that is 0.012. Then raised to the number of months. Your holding period is 14 months. Then the power is 14. Then we can do the calculation. I'm not going to do the calculation. I think, yeah, with the calculator, it is easy for you to find out the value or find out the result of this calculation. All right. Okay. So that is the review of the math. Yeah, we are going to use a lot of, we are going to use this math a lot in our course. You should be very, very familiar. You should understand this math. Okay? Okay, that is the, now we're going, we're going to discuss, after we review the math, we are going to discuss the future value.